Hello friends. In the earlier part, we have seen what is the procedural part for installation of LTspice. Let us now try to understand how I have done it. So you can see in this directory which I have already shown you, C colon users Dr. Sangeeta Joshi data and local. In this my directory, my LTspice is there in this path. So if I click on LTspice, there is a lib file. Okay, so in the lib file, there are three folders which I have already told you. CMP sub and symbol. What I have told you that whenever you are using the spice directive 74hct.lib, then you are supposed to include that file in this sub. So you can see here in the sub directory I have copied this file 74hct.lib. That is one requirement. Another requirement is what? In the symbol SYM folder, you have to copy all the 20 symbols in the 74 series 20 symbols in the same folder which I have given you. So you can see here directly I have copied that in the SYM folder. So this is how I have done the completed the installation. Then you are supposed to shut down the LTspice and now reopen the LTspice. So once you go to LTspice, go to the file tab and then go to the new schematic tab. Now in this new schematic, first you, since we are using now 74 series components, so first you include that. So for including that, what you have to do, you have to go to the edit and then include .op spice directive. Either you can go through edit path, or there is an option beyond this symbols in the toolbar. So I am clicking this, so a window would pop up. So here you choose a spice directive. So dot include 74hct.lib. Okay, so I am getting here this file. Okay, now let us try to see how can we see the whether it is already I mean installed file, whether it will access or not. So that will check. So let us open. So we can have one AND gate 74 this thing. So I have taken an AND gate and let us see whether we can verify the truth table of the AND gate. Okay, so you are extending these wires, then this is the output, right? Now you have to give the labels. A port A, okay, I have given A, here I have given B. I have actually copied the A only, but then I can now here make it as a B, okay? But here I have port type is none. I'm just labeling the inputs, two inputs. Now for the output, I am writing here out and I am labeling the port as a output port. Okay, so I am labeling this as output port. Now I'll select the sources, voltage sources for this. So uh, I am selecting the two voltage sources, voltage. Okay, so one voltage source is here, another voltage source is here. Okay, so I am actually connecting the first source to the first input and second source to the second input. Okay, either you can connect or you can have the same labels here. Anyway, you can, either way you can do this. Okay, so ground you select, connect it to the ground, connect this to the ground. Now to verify whether this is working or not, so before simulation you have to give the what kind of analysis you are, I mean which kind of inputs you are giving. So advanced, supposing I would like to check everything, all four combinations of A input and B input. So I'll have to give some pulse. So initial value, suppose I take V, initial is 5 volts and this is 0. Now whenever the units are given here, volts, then you need not write here again V here. Whenever here it is given V, you need not write. Here it is delay is 0. So I am writing anyway 0 seconds. T rise in seconds. If I want to write picosecond or nanosecond, I'll have to write P or N accordingly. So I am writing the 1 picosecond writes time, 1 picosecond fall time of a pulse. On means what is the on period of a pulse? Supposing my on period of a pulse is 1 microsecond. Okay, so I am writing U, 1 mu. Actually, the symbol is 1 mu, but here it is you have to press key letter 1 U. Okay, and then you take this pulse vertical, slightly reduce the font. Okay, and I am now shifting it appropriately so that it will not. Okay, Similarly, you do it for this pulse. Now, advanced pulse, initial value is 5, next value is 0, next 0, delay, rise time is 1 pico, fall time is 1 pico, T on is 1 micro, and T period is 2 micro. Oh, first I have taken 1 micro, then I have to now take 2 micro and 4 micro, so that I can get all the 4 combinations of the input. Okay. Here by mistake I have taken on period also 1 micro and off total period also, because total period is double of the T on period. So 1 micro and 2 micro. Okay. So you can also have a font slightly reduced, 1. Okay. Let it be like this. One is vertical and one. Now we are ready with the simulation. You can save your file. So run the, what is the stop time? So before that you can simulate, edit run simulation, edit simulation command. So here it will ask for the stop time. Since my maximum period is 4 microsecond, I am taking a 4. So that one cycle is taken. So these are the dot transient 4 microsecond. Okay. Now everything is fine. I have done the logic diagram. I have given the stimulations to the voltage sources. I have included the 74 library, and I have given the transient analysis for how much time, that is the 4 microsecond. Now you run the simulation. So you are running the simulation. So since vertical, normally I prefer tile vertically. And now here what you have to do, you have to give the uh, A, what is the pulse, B, what is the pulse, and what is the output pulse. Okay, output. Now these are all superimposed, so we have to add plot pane. So since these are the 3 signals we are watching, we'll add 3 planes. So A I have shifted up, B I have shifted here, and C is out is here. Now this is a AND gate I had shown you. So you can now see this is this is 0, A is 0, B is 0. So what output I am getting, A into B is 0. A is 1, B is 0. I am getting here the output as a 0. A is 0, B is 1. I am getting the output as a 0. Only when A is 1 and B is 1, I am getting the output as a 1. And that is how I am satisfied with the, uh, or maybe I have verified all the combinations of the inputs, and hence the truth table is verified. Now, one more thing I would like to tell you, sometimes what you will find that whenever you are adding this 74HCT, so that time, sometimes you will find this file is not able to access or not able to open. In that case, what you have to do, in that case, you go to where that is. You go to the file in the directory. I know which directory that file is. So I had shown you my file is here, sub, and this is the file. So you right click that file and see the properties. Okay. And you note down this path, copy this path. This entire path you copy, Control C, and that path, whenever you are not able to getting the message. Now you have to go to the, so it is in the now. So here between include and 74HCT, you actually copy this path. Okay. And here you make a backslash because that is the 74HCT is located there. Okay. So I have now given the entire path in this. So many times that is needed. Okay, I'll make a slightly smaller font so that, okay, okay. So I have made a smaller font size so that you can visualize the entire path. So though whenever you are not getting this file accessible or while running, so you have to include this end. Now once you have done this, then you can edit in that, then you get an option of as a edit. So here you can do any changes. Okay. Even I think you can browse also whenever you are editing it again, you can browse browse option. So wherever your files are, so you can actually go through the browse and upload the right path. Okay. So whenever you are finding the difficulty in having the access in it, then you can run this. So you will get the results. So thank you very much, students. In the next lab, we'll take a Boolean expression and I'll try to give you some more inputs how to run the Boolean expression, implement the schematic, and then get the verification of the results. Thank you.